Start recording, start stream. No problem. We'll start the recording. Okay. So today we are going to start our major topic of NLM, and that is called as basically friction. Okay. Now most of these lectures will be in English because as it is requested by many other parents and teachers that please do these lectures in English. Okay. So we are going to do these lectures in full English and little bit of Hindi words I'll use it in between the classes sometimes. Okay. So let me start this. This word friction. We are going to start with this word friction, why it is used, where it is used, and how it is going to come into the conclusion. Okay. So I'll start with a little bit of one example. Example is, let's suppose there are two blocks, okay, which are kept on top of each other. Now you guys have a very good thing or one good permission that whenever you feel difficulty in understanding, you can switch on your mic and ask the doubts. Is that clear? Is I'm perfectly audible or not? Guys, please reply. Is I'm perfectly audible or not?
Yes, you're audible.
So whenever the problem, you just reply me. Okay. So look over here. See, let's take an example of this two blocks. Okay. One block is of mass m1. Another block is of mass m2. I placed them on top of each other, okay, and I kept them on ground. So if I look on to their normal, so how we draw the normal? Basically, if you look into this particular contact, there are two contacts, one with the ground, another within themselves. So I don't. One, this is my contact one, okay, and this is my contact two. Correct. Now let's just, if I want to see a clear picture of this contact one, in reality, if you try to zoom these bodies, okay, so ये वर्ड याद आ रहा है, zoom वर्ड हम यूज करते थे अपने क्लास में, है ना? So let's suppose if I zoom these contact surfaces, what I'm going to find out that these kind of appearance is there, okay, means on top of each other. This will be the real picture in reality, okay. Now see, basically this concept is a kind of old representation. I'm using not I'm not using a proper uh, real idea. I'm using an old views, okay, how the people used to think. Okay, new ideas are that there are means these surfaces are like this only, and there are attractions between these bodies, which we call it as also van der Waal attraction. Is that clear or not? So instead of going into too much of that, I will just follow this. I will say that these surfaces are not perfectly smooth, means not perfectly plain. They're in some kind of curve shapes like this way. Okay, what is happening over here is that this mass m1 is trying to press the body. Okay, now is the pressing force is basically its weight? The answer is no. The pressing force is not its weight. Okay, the weight is present, of course weight is present, but this weight is actually present till at the center of gravity, towards the center of gravity. Keep that in mind. Is that clear or not? Means this body A or M1 or this body B is not pressing with its own weight. It's pressing with this contact itself. This you can see that there are some sharp edges over here. So these A is trying to press this B with a contact force, which we call it as what? Normal. What we call it as? Normal. Is that clear or not? And now you know that every contact force has equal and opposite reaction. So B also presses A with a normal. Is that clear? So many people ask me that, sir, is the normal action reaction pair with Mg? The answer is again no. Why? Because keep that in mind. The word action and reaction is only for similar kind of forces. Means if I have action of force F1 reaction must be of the same nature of force. Okay, it might be different, it might be less, but mostly it is always same. Is that clear or not? 99.9, only in one scenario it is not same, and otherwise always action and reaction is same. Is that clear or not? So it is always present between similar forces of nature. And second point, you will feel that they are equal in magnitudes. That's why we write equal in magnitude, but opposite in direction. So this is little bit of meaning of this normal and MG and all is that, and contacts. Okay. Now, what I did earlier, I kept this body at rest. Now, I want to move this body. Like I'm sliding this body. I'm sliding over here, one top of each other, here and there, here and there. If the surface is rough, what is going to happen? That as we will try to slide, these surfaces which are in contact, they are going to oppose it. Okay. And then when they are going to oppose it, a new force appears, and that force is called as frictional force. That force is given a name, and that name is called as frictional force. Are you able to get me on? Say me something, Balak, says or no? So
Yes, sir.
let's suppose this is some block M, mass M. Okay. And I apply some force over there. Means idea is that, like, let us just take, let's suppose I apply some force. Okay. So now I'm going into the definition part. So idea is that case one, if this external force is how much? Zero. Means there is no force present on the surface. Then, or not no force present on the body. Then again, what you are going to see, that the opposing force is how much? Basically zero. Now, when you will increase this, if this force is non-zero, if this F is non-zero, what you're going to see, that opposing force appears. Opposing force is not zero. Same as something is on. So this means that this idea of opposing force is appearing. So can I write one conclusion over here? That the opposing force appears only when there is an external force. Only where there is an which kind of force, Balak? External. If my external force is zero, that means that if there is if only when there is an, if my external force is zero, then the opposing force is also zero. Why I'm assuming like this? Now the question arises, or why I'm assuming like this, that because if external force is there, then only it is going to bring some relative motion over here between the contacts. So another way of saying that opposing force, that if this opposing force appears when there is an relative motion between the contacts. So see, there are 2 points. First point is that, Balak, if you don't apply the force, the body is not going to experience any kind of opposing force. If you apply the force, then the body is going to experience some kind of opposing force, because you are bringing the body from rest to some kind of a state of motion. Okay. So idea is that this force, this opposing force only appears when and only when there is a relative motion. Now, if there is a relative motion, it will be present in which direction? For the body M, it will be present in backward direction. But if I consider the ground, it is still present in which direction? Forward direction. Means again, equal and opposite reactions are there. And then this opposing force has given a name, and we call it as friction. So these are all our small clear ideas. Is this clear till now or not? Suruchi, any doubt?
नहीं नहीं नहीं, थोड़ा
Hariom, कुछ doubt? This is the meaning of frictional force. Okay. Now, idea is that let's take an example. See, when these two bodies are overlapping with each other, okay. Uh, let's suppose I'll draw a rough picture, not these extreme pictures. Let's suppose these two bodies are overlapping. Okay. See, on the ground. Okay, and I apply some external force. This opposing force is appearing over here, and for this body, it is appearing in this direction. Okay. Now look over here. When you see, I'm saying that initially the bodies were at rest. Initially, body is at rest. 99% of your NLM questions involve this only. That initial conditions are that they are at rest. Is that clear or not? Now, if my initial state of the body is at rest, what is going to happen? Question arises that what is going to happen when you apply the force? Of course, these bodies will accelerate, correct? But this friction, this word friction, this opposing force will maximally try to preserve the body to be at rest or not, or keep the body at rest or not. Say something is not correct. Means the nature of this force is to be present to oppose this acceleration. Anyhow, this acceleration should be zero. So question arises now, a time will come that where this friction, this opposing force can go to its maximum value or not. Of course, you know that any body is there, it can be moved. Means these forces cannot be infinitely large. Are you going to get me or not? Is it possible that these forces can be infinitely large? Are you getting too many of background noise? No, no.
बीच में आ रहा है
बीच बीच में आ रहा है मतलब हॉर्न का ही आ रहा है ना और कुछ ज्यादा कुछ तो नहीं आ रहा है ना
हाँ बस ऑन था
कभी कभी मतलब उतना तेज शार्प नहीं आ रहा है ना
नहीं ठीक है
हाँ ठीक है उतना ही चाहिए क्योंकि थोड़ा सा इधर रोड पे घर है इसलिए आवाज कभी कभी आता रहता है ठीक तो ध्यान से देखो मैं क्या बोल रहा हूँ व्हाट आई एम सेइंग इज सिंपल थिंग दैट इनिशियल बॉडी इज एट रेस्ट यू आर ट्राइंग टू मूव इट नाउ the work of the friction is to stop it, but you know that the friction, any opposing force can nothing in the universe can be infinitely large. These bodies are going to ultimately move. I have that much efficiency to move the body. So idea is that these bodies between themselves generate, means what can be my maximum stopping force? That is a big question or not? Yes or no? And that is what we have given a name, and that is what is called as, you can say, the word limiting friction. What it is called as, balaks? So for limiting friction. So first thing which we understand in physics in friction is the word limiting friction itself. That okay, you can oppose me, but what will be your maximum value? That's my question. Simple idea is that. Now tell me, let's take an example. Okay, see, let's take an example. If I have two bodies like this way, okay, and I have a small body, word or not, and someone is trying to push it. Someone, okay, after this many years of teaching also, still my, this is M1 and this is M2. Now M1, my drawings are not going to be perfect, so sorry for that, guys. Now look over here, M1 and M2. Someone is trying to push, and the surfaces are basically rough over here. Okay. So my question is very simple. Which body will easily move? Tell me, which body will easily move? M1 or M2?
M2
M2 will easily move. Correct. How you are saying it? Because you are looking into the fact of the mass over there or not, mass or something like that. So here, basically, we don't measure which body will move based on mass. Actually, their measurement is done by normal reactions. These measurements are done by what, Balak? Normal reactions over here. Okay. As we can see that the normal reaction N1 is greater than N2. So for N1, I require maximum pushing force, and for N2, I require less pushing force. Are you get me or not? So this means that this particular value of limiting friction which is appearing, okay, is definitely dependent on my normal. Is that clear or not? More is the weight of the body, less, more, like it will be very, very hard to move it. Is that clear or not? If the weight is more, is that clear? So means I can say that friction increases as the weight increases. Are you able to get me or not? Is this clear or not? Now, second idea is that when you will remove this proportionality, what I'm going to get is F limiting is given as mu L, and mu limiting we call it as, and into L, where mu L is called as coefficient of limiting friction. Now, idea is that if you look over here, let's take another example. See, same masses are there. Okay, same mass block. Okay, what I'm going it, simple thing is this time I am arranging like this. They are same bodies. You saw that. I just copied and pasted it. And the surface is rough. See, question arises, does both of them will experience different friction or same friction if some force is applied? Tell me. Viraj, tell me. Same or different?
Same.
Huh?
Same.
Same. The masses are same. So frictions will be also same. Are you sure?
Yes, sir.
Yes. The answer is correct. Basically, idea is that, see, here area of contact is more, but the total pressing, like everywhere, this normal is spreaded everywhere. Means this particular pressing forces are spreaded. But here, contact is tensed, but area is less or not. So what is happening is that somehow they are balancing it, and we will say that friction is independent of area of contact. Are you with me or not? This is the point. Are you able to get me? So we got the meaning of limiting friction. We got the meaning of this friction, whether it will be dependent on contact surfaces or not. So we got also a correct idea. So it is not dependent on contact surfaces. Now let's take an example. We are going through an example right now. It's a very great example which I always take when I teach friction. Okay. Today your basic concepts of everything friction will be clear. Now let's suppose again there is a mass M. Okay. And on this mass, I am applying some force which varies between a range, some range. Okay. I said that means I just did one experiment and I told that maximum value of friction which can be present is basically 10 Newton. And basically this I am going to call it as F limiting. Correct? Are you able to get me or not, Balaks? Now, look over here. Let's take an example. Case 1. Okay, I'm not going to write all these cases. Simple idea. First case, when force applied is 2 Newton. My question is very simple. Does the body moves or not? Tell me. Does the body moves or not? Guys,
Same.
the body is not moving. Because you know that basically means the friction which can be maximally generated is 10 Newton. Means if you are not applying a force which is more than 10 Newton, the body is never ever going to move. Why is that? Because see, idea is that let's suppose I apply 2 Newton force. The body has an eligibility to oppose this 2 Newton because always the body's condition is that it will oppose the motion. So it can easily apply 2 Newton or not. Why? Because it's there. Like it's, let's suppose I'm in India and we have some missiles and I want to fire in America. But idea is that our missiles has a range of 5,000 kilometers. Can I hit America? The answer is no. But I can definitely hit Pakistan because it is at just 200 kilometers away from here. Yes or no? So if I hit Pakistan, I can, why I can hit Pakistan? Because it is in my range or my method of applying. So here also same thing. Maximum range the body can oppose is 10 Newton, but I applied only 2 Newton. So what happened? Body does not move. Now, if body does not move, then what is happening? Something is opposing it. Someone is opposing it. Well, who is that someone? Basically, it is that frictional force or what? Say me something is on. It is that frictional force which is present over here, and that frictional force which is opposing it. Now, you know that if body is not moving, the opposing force must be equal to, means right force is equal to left force. That's the condition of equilibrium. This means that this time friction, frictional force present is equal to just how much Newton? 2 Newton, definitely. Now, same thing when F applied is basically 5 Newton. Still, you are going to observe the body does not move. Now, if body does not move, again, this frictional force must be equal to opposing external force applied. Then only net force will become 0 because body is not moving. So, frictional force present is equal to how much Newton? 5 Newton this time. Are you able to get me or not? So this is what is the conclusion of friction. See, there is a maximum limit that is going to be present at certain situations, and we can be sure of that. But when my F applied is less than my limiting friction, means less than my maximum value of friction, then the body self-adjusts this opposing force according to external force or not. Say something is or no, and body remains at rest. This kind of frictions which are self-adjusting in nature, are called as static frictional force. So first idea of this static frictional force, just now we proved it, they are self-adjusting. Simple idea. Self-adjusting force. Second idea is that present when the body is at rest. Third idea is that it is present when my F applied force is less than my F limiting maximum value of limiting friction force. Is that clear or not? Fourth idea is that again this will be also independent of area of contact, and second, velocity of the bodies, and this is always equal to, or we can say this is too much, so I'll write simply always equal to F external if F external is less than maximum value of friction applied. Friction, maximum value of friction. Is that clear or not? Now, so idea is that a static frictional force will be definitely present when the body is at rest, and if there is an external force. Is that clear or not? So this means that now at that time, like there is a contact over here. So this mu limiting which we are writing means to describe this, what kind of contact is there. This mu limiting describes that which kind of contact I'm talking about, like if is a, whether it is too much rough, whether it is little bit rough, or what kind of contact. So these all things are talked by this mu limiting. Now, as you see that when F limiting I'm applying, this is the state. This is also the state when it is, when this is also the force present when the body is still at what? Rest. Means I'm saying something. Let me just be clear, first of all. Means I applied some F external, and this F external is exactly equal to F limiting. Now understand. Third scenario. When F applied is exactly equal to 10 Newton. Does the body will move or the body will remain at rest? The body does not move. Correct? Still the body does not. But this is my maximum value of F applied or not? So idea is that even if you apply limiting friction, the body is going to be at rest only. Is that clear or not? So this is why sometimes this mu L, what is appearing over, to talk about that roughness of the region, to talk about that, whatever mu L I'm considering, this is also written as mu S. Okay, why it is called as mu S? Why? Because the body is still at rest. Are you able to get me or not? So till this, everything is clear on. Saroj, clear?
Yes, sir.
समझ में आया? हरिओम क्लियर है? कुछ डाउट? मतलब बात नहीं है भैया, आप बॉडी को दौड़ा रहे हो तो बॉडी पहले उस चीज को अपोज करेगी जितना उसके में दम है। अब जितना दम लगाया, कितना ही दम लगा सकता है, मैक्सिमम थोड़ी ना लगा सकता है। मतलब एक ना एक टाइम पे तो बॉडी तो मूव करेगी ही करेगी। तो जब हम फोर्स अप्लाई कर रहे हैं, जितना देर तक वो अपना दम खम लगा रहा है, वो एग्जैक्टली मेरे अप्लाइड फोर्स के बराबर होगा। और वही उसी चीज को हम बोलते हैं स्टैटिक फ्रिक्शन। एक टाइम आएगा जब तुम्हारा फोर्स उसके बैरियर को ब्रेक करेगा, भाई उसकी प्रेजेंस को ब्रेक करेगा, और उस टाइम पे कौन सी फोर्स लग रही है? तुम्हारी फ्रिक्शनल लिमिटिंग लग रही है। और वो लिमिटिंग क्या इसके ऊपर डिपेंड करेगी? एग्जैक्टली नॉर्मल नॉर्मल के ऊपर। लेकिन स्टैटिक नॉर्मल के ऊपर डिपेंड नहीं करेगी, क्योंकि स्टैटिक तो बॉडी का दमकम है भाई, वो दमकम के हिसाब से लगाना है। समझ में आएगी नहीं आई बात पूरी तरह से? ठीक है, तो क्या हम आगे बढ़े? तो means idea is that static will never be equal to F limiting. Means static will always be equal to only F applied. Is that clear or not? And F limiting is basically my maximum frictional force which can be present in the bodies. At which state? At the state of rest. And this is why we call also sometimes mu limiting, which is appearing as coefficient of friction over here, as mu static also. Is that clear or not? That's the conclusion. Is that clear? Now, what happened? We took the case fourth. Now, here, if I define case fourth, okay, so in this only, wait, case fourth, when the applied force,
सर इस थर्ड केस पे एफ नेट 0 हो जाएगा।
कहाँ पे?
थर्ड केस पे एफ नेट 0 होगा।
फ्रिक्शनल फोर्स 0 होगा।
एफ
नेट तो हर केस में 0 है। अच्छा, इसमें देख, अप्लाइड फ्रिक्शनल फोर्स कितना हो गया? 2 न्यूटन।
अच्छा इक्वल है।
हाँ, तभी तो बॉडी मूव नहीं कर रहा है। बॉडी मूव नहीं करेगा तो हरदम ही एफ नेट क्या है? 0। तीनों केस, इन एवरी ईच वन ऑफ देम the value of f net is how much? 0. Why it is that? Because body is at rest. Simple idea.
जब तक स्टैटिक फ्रिक्शन है तब तक एफ नेट 0।
जब तक लिमिटिंग तक f net is 0, क्योंकि बॉडी मूव ही नहीं करेगा। और जैसे तूने बॉडी को मूव कराना स्टार्ट कर दिया, मान ले अगर मैं बोल दूं कि सर in this friction, see, idea is that let's suppose I applied a force which is exactly equal to 10 Newton and limiting is working, and if I apply means at that time instead of body to be at rest, this starts to move with constant velocity. So is that if limiting is acting? No, at that time, at that instant itself, this friction will change and it will change into kinetic friction. Which kind of a friction? Means as the bodies, when the applied force makes the body to move, makes the bodies to have relative velocity between the contact surfaces, then new friction, new frictional force appears. Okay, and that is called as kinetic friction. It is called as which kind of friction? Kinetic friction. Is that clear? Means as soon as the bodies start to have some motion, again they will have some kinetic friction. Let's take an example. Like idea is that you are driving a truck on a road. There are two things. There is a truck. Okay, and then there is a car. Okay, two things are there. Now, this is your truck one moving with some velocity p1, and this is your truck two moving with velocity how much? V2. Now, engines are a stop. Okay, and the surface is rough. Okay, tell me which one will stop faster? Assuming that this is mass m1, this is mass m2, m1 is greater than m2, and I'm assuming v1 is equal to v2. Out of this, which one will stop fast? Hmm? Tell me. If I switched off the engines, which one will stop fast? बताओ. देखियो ना, अरे फ्लैट रोड पे मान लो तुमने
M2.
ऑफ कर दिया इंजन, कौन सा जल्दी स्टॉप हो जाता है? पहला स्टॉप हो,
M1.
m1 will stop. So this means that, see, this, if we simple, this one stops earlier than truck 2, correct? This one stops faster. Achha, if this one stops faster, does this means that the friction is different on both of them or not? And it is dependent on weight or not? Means my opposing force which is appearing over here, F, which is appearing, that opposing force is definitely dependent on my weight of the body once again. So this is why we gave the heading again as kinetic frictional force. Okay, and this kinetic frictional force appears, first of all, appears when the bodies have relative motion between their contact surfaces. Between the which kind of surfaces, Balaks? Contact surfaces. Again, this is also dependent on the normal, independent of area of contact, and independent of area of contact, and independent of, basically you can say, even velocities between the surface. Is that clear? Did you understood, or guys?
How is it independent of velocity?
How it is independent of relative velocity? So see, whether it is v1, let's suppose if this v1 would have been higher and if this v2 would have been lower, this truck would have stopped after later time or not. See something is or no? Now, if it would happen dependent on velocities, whether it will increase or decrease the velocity, this friction will stop it at the same time. But is it happening like that? No, no. So idea is that, see, it is dependent on relative motion. It is saying that it is dependent. Means if you move it, I'll be present. But I am not going to say that whether if you move faster or whether you move slower, my values will change. Is that clear or not? If you move slower, same values will appear. If you move faster, also same value of friction will appear. Is that clear or not? And this is why faster body takes some time to slow down and slower body stops faster. Is that clear or not? Is that clear now? अगर मान ले वेलोसिटी पे डिपेंडेंट रहता तो वो वेलोसिटी के हिसाब से चेंज कर लेता ना. वेलोसिटी तेज हुई, मैंने फ्रिक्शन बढ़ा दिया ताकि मतलब गाड़ी जल्दी से रुक जाए. ऐसा होता है क्या? नहीं ना, ऐसा तो सुना नहीं है. दिस इज द मीनिंग दैट it is not independent. It is independent of relative velocity. Why it is independent? Because it cannot change its value according to velocity. Okay, and this is why this kinetic friction is written as, again, dependent on what? Normal. But this F kinetic is written as the, basically you know that the contacts will, in the relative motion there will be less contact, so we give the coefficient of friction as mu. Okay, okay. Why? Because I have a different kind of contact, right? Is that clear? Now it is not self-adjusting, it is totally dependent on weight of the body. Are you get me or not? So this is why when we try to draw the graph of friction versus force which I am applying, and any body, let's suppose assume that some body is at origin, at initially at rest. So you know that as you will increase the F applied slowly, first of all, the friction will increase. The friction will try to self-adjust, and we call it as that range as static friction. Got it or not? Then after that, what will happen? This friction will grow to its maximum value, where it will suffer deformation. Why deformation? Because F applied is still increasing. So this maximum value will suddenly break and the body will start moving, and after that it attains a kinetic friction which is just dependent on weight. Okay, now basically F kinetic and F limiting are almost same. Why it is different? Because of the reason that when it is in limiting, it is in state rest, and at a state condition I'll have maximum contact, means the bodies will fully overlap on each other. There will be very less spacing left. But in F kinetic, as the bodies are moving, what is happening? There is less spacing between the bodies. This is why we draw this region. We draw a dip down over here. Means there is a deep place. Is that clear or not? I will get me out. This is only appearing. Why? Because mu k is always less than what? Mu s or mu. Are you able to get me out? Clear?
Yes, sir.
Okay. Now, so one best thing about friction, I'll tell you one thing. First of all, in every frictional case, this is called as ATH. Everyone knows over here. Now I have given my theorems a name, and it is called as Anurag-Sir theorem. Suddenly, after some years, I might get Nobel Prize, if possible, if there is some possibility. But right now, I'm not going for that. I'm just looking into some other facts. Now, ATH says that whenever you are solving friction-related NLM problems, always step one is always find limiting friction. This is why I taught you this in the beginning. What you have to always find? Limiting friction. Second step will be find friction required on the body, or which is present, required or present. And then you have three different cases. If F required is less than F limiting, the body moves. And if F required, if F required is less than F limiting, the body does not move. Right or not? And if F required is more than F limiting, what is going to happen? The body is going. So you have to always find two things. What are those two things? Limiting and required. Is that clear or not clear? Are you with me? So let's do some examples. Okay. I don't do nowadays tough questions. Okay. अबे मतलब पहले लोगों को लगता था कि मैं बहुत टफ पढ़ाता हूँ, लेकिन अभी देखो मेरे उसी पढ़ाने की वजह से मार्क्स आते हैं कि नहीं? अब लग रहा है कि नहीं लग रहा है कि सही चीज पढ़ा रहा हूँ?
वो जब मॉडल सर ने पढ़ाया था तभी क्या चल रहा है, क्या हो रहा है।
Yes.
आगे कुछ नहीं बोलूंगी।
So let's suppose there is a block of mass 5 kg and it is experiencing a force of what I'm doing, I'm applying some force. What I'm saying is on this surface there are two mu's. Mu s is given 0.2 and mu k is given 0.15. Question is find the acceleration of block and friction present when first F is equal to 1 Newton, second F is equal to 2 Newton, and third, actually let's do one thing, just change this to 2 kg. And third, F is equal to 2.5 Newtons. Okay. More, let's do one thing. Let me little bit change it. Okay. 1 Newton, 4 Newton, and do this question at 5. Okay. I'll take a small break. Do it fast. हाँ बताओ।
नॉर्मल का फॉर्मूला होता है मास इनटू ग्राम।
हाँ हाँ
सॉरी ग्राम।
हाँ हाँ,
एम पता है मुझे।
एम तो पता ही है।
जी को हम
हाँ हाँ,
जी का रेट करने से 20 का जाएगा। तो जो हमें रिक्वायर्ड है वो 20 है।
नहीं 20 नहीं होगा ना। पहले तो अच्छा देखो, मैंने स्टेप में पहले क्या बताया, लिमिटिंग फ्रिक्शन फाइंड आउट करने के लिए ना।
फर्स्ट एक्सेलरेशन 0 और फ्रिक्शनल फोर्स 1 न्यूटन। सेकेंड में एक्सेलरेशन 0.5 और फ्रिक्शनल फोर्स 3 न्यूटन। थर्ड में
कैलकुलेट करो।
एक्सेलरेशन 1 और फ्रिक्शनल फोर्स 3 न्यूटन।
तो देखा जाए सुरुचि। सुरुचि,
फर्स्ट और सेकंड में एक्सेलरेशन 0 होगा।
फर्स्ट और सेकंड दोनों में एक्सेलरेशन 0 होगा।
हाँ, क्योंकि एफ एन 4 न्यूटन आ रहा है।
यस, एक बार देखते हैं। तो इफ लिमिटिंग हम पहले कैलकुलेट करते हैं फर्स्ट। हरिओम देखना, फर्स्ट व्हाट आई हैव टू कैलकुलेट, एफ लिमिटिंग। एफ लिमिटिंग इज व्हाट, क्या बताया था फॉर्मूला, म्यू एस इनटू एन नॉर्मल। यहाँ पे नॉर्मल क्या किसके बराबर है, ट्वाइस डी के बराबर है या नहीं है। सो लुक ओवर हियर, एफ लिमिटिंग बराबर क्या आ जाएगा, व्हाट विल बी माय एफ लिमिटिंग, इट विल बी mu s into n, which is 0.2 and normal is 2 into 10. So basically f limiting I'm getting over here as 4 newtons. Got it or not? Now first case, f applied, look over there, this f applied is less than or more than f limiting, less than f limiting or not. So this implies what, acceleration will be how much, 0. And friction, basically frictional force is going to be my f static, and at that time what will be that, according it will be exactly equal to f applied, yes, 1 newton. Same something yes or no. Second scenario, f applied is exactly equal to what, f limiting. Now I told you if it is exactly equal, then again acceleration is going to be how much, 0. And f will change to frictional force will be limiting frictional force, and that will be equal to how much, 4 newton. Now third scenario, as what happened, if applied becomes greater than f limiting, then what is going to happen, this particular body will have acceleration, yes or no. And how do we write acceleration, I'll tell you one again, another ATH, okay, keep that in mind. Whenever, see, on a surface, let's suppose there is a body, okay, of mass m, okay, and there is something, this is basically f which is pushing it, and f which is pulling it, and then there is an acceleration along this side, okay. So look over here, there are two kinds of forces, f which is trying to push, and f which is trying to oppose. So basically acceleration is simply equal to f which is pushing it or pulling it minus force which is opposing this motion divided by total mass moving. That is the concept of acceleration. That is the concept of what, Balax? Acceleration. Same something, yes or no? So look over here. If you consider this F applied as this time 5 Newton, which is more than F limiting, so this F limiting will change. It will not be F limiting right now. It will be changed into what? F kinetic. Same something as well. At that time, acceleration will be what? Pulling force 5 Newton minus F kinetic divided by what? Mass M. Now F kinetic is what? Mu K into N normal. And what is that? 0.15 into normal is how much? 20. So this will be how much? Suruchi, कितना आ रहा है आपके?
3 न्यूटन।
So that is how much? 3 Newton. So this means that acceleration will be how much? 5 minus 3 divided by 2, 1 meter. हरिओम समझ में आया कि नहीं आया?
F is equals to ma.
क्या क्या?
F is equals to ma.
एफ एस फिर से बोल जरा.
F is equals to ma.
हाँ, एन एन
उसके
ए
निकाल दो. F
एफ एस.
F is equals to ma वाले फॉर्मूला से निकाल दो.
ओके, हाँ. अच्छा
इसके अगर एक्सेलरेशन निकाल दिया तो
अच्छा, मतलब तू बोल रही है कि मैं अगर एफ डायरेक्ट फॉर्मूला डाल दिया 5 न्यूटन इज इक्वल टू मास इनटू एक्सेलरेशन, और मास की जगह पे मैंने 2 केजी रख दिया.
हाँ.
बट एक बात बता, यहाँ पे क्या तूने एक्सेलरेशन सिर्फ एक ही फोर्स की वजह से थोड़ी ना आ रहा है. Acceleration जो होता है, this is what is the biggest problem of Newton's second law, that you have been taught F is equal to ma, but this is not F only, Balak. This is F net is equal to ma, not only F. Is that clear or not?
Okay.
This is why Newton's second law is said as dp vector by dt. This is Newton's second law. If you say F is equal to ma, is this is Newton's second law? The answer is no, sir. This is not. If I write F net is equal to ma, that can be called as Newton's second law. Are you with me or not? Okay, so idea is that acceleration is not only created by applied force. Acceleration is the effect of resultant force, and this is why I wrote this formula. Resultant basically means only same thing: a push minus opposing divided by total masses which are moving. Is that clear or not?
Yeah.
Are you able to get me? Now, last topic for today, and that after that tomorrow onwards again we will begin. Tomorrow be punctual, guys. Everyone, sharp 9:15. Okay. Now, let's take an example, and this is called as angle of friction. Okay. Now, idea is that, let's suppose on a surface, I kept a block, and on this block, I applied some force. This surface is rough. Okay. Now, you can see that if I look into the FBD of it, then this will be my normal. Okay. Wait for me. Let me draw this. And this will be my direction of what? Friction. Correct? Whatever friction is going to be present. Is that clear or not? Now, so look over here. This is my normal, and this is my what? Friction. So basically, if you look into that, N and friction, both are basically my contact forces. Or reply me louder, yes or no? So idea is that there will be definitely a direction in which what will act? Resultant contact force will act. What is going to act? Resultant contact force is going to act, and this resultant R, or which we write it as C. Okay, C is going to be what? Root over n square plus f square. Why n square plus f square? Because we can see that here there is means the angle between n and f is how much? 90 degrees. Now, the angle which this resultant contact force makes with the normal vector or the vertical direction is called as basically angle of. Is that clear or not? Angle between the resultant contact force and the normal vector. Okay, now idea is that this C value will be maximum and minimum weight. Means you look over there, this frictional force, you know that it can be equal to F and all. Okay, so if I look into the maximum value of this contact force, okay, it is basically present at limiting condition. So this is why it can be simply written as, see, at limiting state, this frictional force is equal to mu n, So maximum value of this contact force is simply equal to n into 1 plus how much? Mu s. Is that clear? This is the maximum value of this contact. Is that clear or not? Say me something, yes or no? Are you able to get me?
Yes, sir.
हाँ बताओ, बोलो हरिओम।
Yes, sir. बोलिए।
हाँ हाँ हाँ, क्या
समझ में आ गया, समझ में आ गया।
समझ में आ गया? क्लियर है?
Yes, sir.
ठीक, तो अपन कल मिलते हैं फिर से, ठीक है? थोड़ा और आगे बढ़ाएंगे चीजों को।